Good day, everyone. My name is Sajjad Alami, and I'm a PhD student at Shahid Beheshti University in Iran. I would like to share with you an overview of my recent study called The Investigation of Visual Temporal Processing Across Different Tasks and Age Groups, Rapid Temporal Recalibration, and Time Window of Integration. First, I would like to say the goals of this study. The first aim is investigating the relationship between rapid temporal recalibration and the time window of integration as two important and influential factors in multisensory temporal integration across different tasks in adults. The second aim is examining the developmental process of rapid temporal recalibration and temporal window of integration from childhood to adulthood using the temporal order judgment or TOJ task. Using this explore whether these two key factors have the same developmental trend or not. And the last one is investigating the impact of individual differences on the effect of rapid temporal calibration across different age groups. Temporal proximity. One of the important factors in multisensory integration is a concept called temporal proximity. Temporal proximity is crucial for integrating events across sense, allowing us to perceive unified experience rather than disjointed or separated sensory inputs. For these reasons, one of the most important fields for studying multisensory integration is multisensory temporal processing, and many studies investigate it. In dynamic processing multisensory integration, one of the challenges is the differences in the propagation speeds of light and sound. To address this, our brain uses two mechanisms. The first is temporal window of integration. The window allows our brain to combine sensory inputs that happen within a certain time frame. The width of this window is variable and flexible across different people, tasks, and age groups. The second mechanism is temporary calibration. Temporary calibration refers to the abilities to brain's ability to adjust its perception of simultaneity based on repeated exposure to asynchronous stimuli. Studies have shown that repeated exposure to an audiovisual asynchrony can shift the point of subjective simultaneity or PSS towards the leading sense of that audiovisual asynchrony. Um, Uh, Van der Broek and colleagues showed that this shift in point of subject simultaneity or PSA doesn't require repeated exposure for a long time. It can happen after just one trial. In this study, we intend to study this type of recalibration, which is called rapid temporal recalibration. There are two types of after rapid temporal recalibration, positive or negative. Positive rapid recalibration happens when participants become less likely to positive synchrony when presented with similar timing relationship in consecutive trial. Negative happens when participants are more likely to perceive synchrony when presented with a timing relationship similar to the previous trial. Uh, there are many different paradigms for measuring time window of integration and rapid temporal calibration. But two of the most important ones are the simultaneity judgment or SJ and temporal order judgment or TOJ. In SJ, subject must determine whether two stimuli that presented different SOR, different stimulus onset asynchrony or SOR, are simultaneous or not. In contrast, in TOJ, require the subject requires the subject to decide which of two stimuli, visual or auditory, was presented first. Regarding the time window of integration, previous studies have shown a significant difference in the size of the time window between these two paradigms. And in terms of rapid temporal recalibration, studies indicate that the SJ task creates a negative rapid temporal recalibration effect, while the TOJ task results in a positive rapid temporal calibration. Some studies have demonstrated a significant relationship between the width of the time window and the negative rapid calibration in the SGA task. The wider the window, the greater the rapid calibration effect. In this study, we will examine this relationship in the TOJ task as well, focusing on its positive rapid calibration effect. Furthermore, we also examine this relationship from a developmental point of view. To our knowledge, most developmental studies investigating the relationship between the developmental of the time window and rapid temporary calibration have used the SJ approach. For this reason, for this reason, in the next phase of our study, we aim to examine the developmental relationship between these two mechanisms using the TOJ task and compare the results with previous studies use the SJ task. In this study, we have three groups: children from 8 to 11 years old, adolescents from 12 to 17 years old, and adults from 18 to 30 years old. Of course, we made this classification based on previous developmental studies. For the adult group, we administrated both SJ and TOJ tasks on two different days. For the adolescent and child groups, we only performed TOJ tasks to examine the developmental trend from childhood to adulthood using the TOJ task. In this study, similar to some previous studies in this field, the SJ and TOJ tasks are designed as a computer game in which participants must identify fireflies based on the sound and light patterns they exhibit. As you can see in this picture, the task design is identical for both the SJ and TOJ tasks, with one key difference. In SJ, participant must determine whether the firefly sound and light happened simultaneously or not. In TOJ, participant must determine whether the light or sound of firefly came first. The type of trial in these two tasks are as follows. Visual only. Visual only trial, that visual stimulus is presented alone. Auditory only trials that auditory stimulus is presented alone. Audiovisual trials that both stimuli are presented with different stimulus onset asynchronous. Positive SOR, the visual SOR comes earlier than the auditory stimulus, and negative SOR, the auditory stimulus comes earlier than visual stimulus. And at the SOR equal to 0, visual and auditory stimuli are presented completely simultaneously. As you can see, SOR value range from 20 to 400 milliseconds. To analyze the data, we first calculate the percentage of simultaneous response for the SJ task and the percentage of detection of visual first for the TOJ task for each SOR in each individual, taking into account both independently and dependently of the nature of the preceding trial, whether the preceding trial was a audio leading or visual leading presentation. For each participant, in each condition related to preceding trial, we fitted a function, a sigmoid function for TOJ and a Gaussian function for the TOJ. We then calculate the time window of integration and point of subjective simultaneity or PSS parameters for each condition, each individual. In the sigmoid distribution, the parameter GND GND is a function of temporal window, and in the Gaussian distribution, ST parameter is a function of the temporal window of integration. And finally, using a statistical test, we compare these parameters dependently and independently of the nature of the preceding trial, precedent trial across different tasks and age groups. Okay, let's talk about the result of this study. First, I'll examine the relationship between the time window and rapid temporary calibration across two different tasks. In the first part, we will talk about TOJ results. As shown in the picture, we divided each person's data for each SOR into two categories based on the preceding trial. Those preceded by a trial with a positive SOR represented by the blue plot, and those preceded by by a trial with a negative as well, represented by the red blood. Um, our results of statistical tests revealed a significant difference in the PSS parameter between these two conditions, indicating a rapid temporal recalibration effect or PSS shift in the TOJ test. Of course, the type of rapid temporal recalibration is positive. However, despite the significant difference in PSS, um, there was no difference in the extent of time window. In other words, effect of preceding trial, despite creating a positive rapid recalibration, has no effect on the time window in TOJ task. In this picture, it's clear that the value of rapid temporary calibration or delta PSS had no relationship with the time window of subject in TOJ task. Regarding the SJ, the results are quite similar to those of the TOJ task, with one key difference. We observe negative rapid temporal calibration instead of positive rapid recalibration. Despite the significant difference in PSS, there is no significant relationship in terms of window. There was still no significant relationship between the size of time window and rapid temporal calibration value. In summary, there is no relationship between the time window and rapid temporal calibration, whether positive or negative, across either the TOJ or SJ task. Next part of this study, we investigated the developmental trajectory of the time window and rapid temporal calibration in three age groups: children, adolescents, and adults. Initially, we explored the difference in time window and PSS parameters among different age groups, regardless of preceding trial conditions. Our result indicated that there is no significant difference in the PSS parameter between these groups. But regarding the time window, the bits of time window in children group is significantly smaller than adolescents, and but there is no significant difference between adolescents and adult. In the time window. In other words, bits of the time window in TOJ test during adolescence becomes similar to adults and reach full maturity. Uh, Unlike the time window, a rapid temporal calibration follows a completely different developmental trajectory. As shown in the picture, there uh, as shown in this picture, there was no positive rapid recalibration effect for the TOJ task in children and adolescents. However, this positive rapid recalibration effect was observed only in adults. To further investigate why rapid temporal recalibration was not observed in adolescents and children, we examined this recalibration effect individually in each group. Here you can see the effect of rapid temporal calibration individually in the child group. As shown in the picture, there are significant individual differences in the rapid temporal calibration effect within this group. Some children display positive recalibration, and some children and others show negative rapid recalibration, and some do not exhibit any recalibration at all. Similarly, in the adolescents group, there are also considerable individual difference and heterogeneity in the rapid recalibration results. This variability among individual in both the child and adolescent groups contributes to the overall lack of a consistent rapid temporal recalibration effect. Unlike the previous two groups, but in adult group, these individual differences and heterogeneity in the rapid calibration effect are minimized. In general, almost none of the adults show negative rapid calibration effect. Additionally, when we compare the values of PSS change or delta PSS as a function of rapid temporal calibration across different age groups, we clearly observe this heterogeneous difference. The dispersion of delta PSS values in the child group is larger than in the adolescence group, and the dispersion in adolescence group is larger than adult group. Then we can say that as age increases, individual differences in the effect of rapid temporal calibration in TOJ task decrease. Okay, according to the result of this study, there is no relationship between rapid temporal calibration and temporal window of integration in the SJ and TOJ tasks in adults. Although previous studies using the using the SJ task reported a relationship between time window and rapid temporal calibration, but the result of this study didn't show any relationship either with the SJ task or with the TOJ task. The developmental result of this study showed that there is no significant difference between adolescents and adults in terms of time window size, but there is a significant difference in rapid temporal calibration. This suggests that these two mechanisms in the TOJ task follow different developmental trajectories. Also, adolescents and children show a heterogeneous and mixed pattern of rapid temporal calibration with both negative and positive effects, while adults consistently exhibit positive rapid recalibration. These findings suggest that the effect of rapid temporal calibration becomes more homogeneous only in adulthood. Our study suggests further research on the role of individual difference in the development of multisensory temporal processing in the future. Thank you very much.